So today I'll be bringing my research to a desktop application to help speakers switch slide by using AI and voice recognition, which therefore I name it Slidecontroller. So I will be explaining my research in the four following table of contents. So I'll be doing like introduction first, which is I'll explaining the purpose and current methods that was already been used. Secondly, I'll explaining the challenges. And third, I'll explaining the procedure, which is like the final solution, prototype, and then the steps that I take to achieve this goal. Lastly, I'll be introducing the experiments that I do to find the best solution that could solve like the power problem. So first, I would like to start with introduction. So what was the purpose of creating Slidecontroller? So as we can tell, in modern society, almost everyone need the skill of presenting. Like on the right picture, we could see Bill Gates and Tim Cook, they're like presenting, and you can see that on their hands, they're holding a slide remote, which is what we always use when we like presenting. And whether it is like on a working place to like reports, and like this skill is really important for everyone. And then therefore I created this called Slidecontroller to better assist the presenter while they're presenting, and also implementing the goal of hands-free and allow the user to have more hand structure while they're presenting. And moreover, it's to reduce the anxiety and less worry on the technical issue of their slide deck switching. And also, of course, like bring more convenience and efficient while the presenter is presenting. And also, the fundamental goal of this is to replace the use of traditional slide remote and for the user to like use your voice to control their slide pace. And of course, lastly, disability groups, where the group of people that are not able to, like, for example, control their slide with their hands, then they could just simply use their voice to control the slide. So I would like to introduce the two current methods that was already being used. Like I mentioned before, the traditional slide remote, it's really commonly seen while people are presenting. So it could be used to control the slide deck with clicking up and down bottom on like the slide remotes. But I will also like to point out some weaknesses of using a traditional slide remote. First of all, is that usually we will like hold the slide remote in our hands, but some people may not be comfortable with holding a slide remote in their hand, while that might increases their anxiety while presenting. And secondly, it's the battery health, which we don't know how long a traditional slide remote will be last, and that might be dead really quickly while like during your presentation. And the second method that was actually being developed was by Google in 2018. It's called Google Slide Remote, but it just basically moved the traditional slide remote instead onto the phone. But there is also a really obvious weaknesses that was being pointed out here, is that the this Google Slide remote is only applied to the slide made with Google Slide, which is really limited. That means like if you create your slide with PowerPoint, you're not able to use Google Slide remotes. And it has also become very inconvenient and unattractive on a serious occasion. Like right now, I'm not gonna use my phone, and then I'm gonna like scroll back and down with like controlling my slide. And also like in this situation where like cell phone are not allowed to use, so that will be really inconvenient. And therefore, I brought up the idea Slidecontroller. It's a desktop application based on AI recognition technology by accurately receiving the user voice, and it collects data and analyzes the hidden keywords from an audio file and connects them to the up and down arrows on the computer keyboard to make the relative commands. So before we go into the challenges that I have faced during my research, is I want to point out the three main chords that was being used to build up Slidecontroller. The first one is the command, which is a built-in keyboard module where the computer could able to control your keyboard, which is the up and down arrow on the keyboard that was used for going back and forth between your slide deck. Second is the keyword, which is the most important things that the user could either choose to customize their own keyword, or they could use the default keyword, which is like next and previous. And what I mean by customized keyword is that the user could enter like, please go to activate the command, which is like going back to a slide or going next to a slide. And this is really helpful because it gives the user more freedom on what they want to do that best fit their presentation flow. Lastly is voice activate, which is also a main core, which is using a voice recognition technique that was really commonly seen, which is a speech to text technique. And basically what it was being used in Slidecontroller is that as the keyword being detected, it will activate the voice recognition and then also do the following command. As the user say like next, then it will go to the next slide. As the user say like previous, then it will go to the previous slide. Next, I would like to go into the challenges that I have found, like the main challenges that I have found during my research. First is efficiency plus accuracy. So, like as I said before, like the core of Slidecontroller, it's a clever use of existing like AI voice recognition technology to connect to the front and back keywords on the keyboard for controlling. Therefore, the voice recognition library needs to be really carefully selected. And the most basic requirement is that it should be able to run on both Windows and iOS platform without any problem. So then it is accuracy of like receiving the voice from the user. And in the Slidecontroller system, accuracy is very important because the computer needs to store the correct data to output the right command. But the existing AI speech recognition technology is limited to inclusiveness. For example, like when the user have like more than 6 or 7 second pause between their presentation, only when the user speak like perfect English and there is no pause, the speech recognition will be able to 100% do the right command. And also the next problem, it's like the efficiency affected by the accuracy of the speech recognition. And so then without a correct recognition of the user voice input, the Slidecontroller, it's unable to complete the command by switching slide the first time. And the existence of Slidecontroller is meaningless if it cannot respond to the user needs in the first place. And this is like the biggest challenge of this desktop application. It's how we can like improve the voice recognition by using different algorithms. Secondly, it's the voice receiving. The first thing is sampling. So we need to determine which second that we want the microphone to pick up in order to do this speech to text processing. So it's really hard for us to know before the user had input their customized keyword, because when the user wanted to do a customized keyword, we need to able to know how many seconds does it take for the user to say that specific keyword so that we could sample the last few seconds so that it wouldn't take that long. The second thing is the environment. If the environment is not like quiet or it have like some noises, it will immediately affect the voice recognition to receive the voice. And third, it's quantization, which is the data points that we use to store it, and which mean lower quality of the voice, the faster it will do the speech to text processing. Lastly, it's the signal processing, which is the process where it will do a speech to text. It's speech to text from the audio file that was already being stored, and it will group the data points that were from the sampling, and then it will convert it to text. And of course, all of these challenges are being solved by finding the best solution. And next, I will be introducing the procedures and the final step that I take to complete Slidecontroller. So this is the prototype that I first created to show an overlook of the Slidecontroller. And as shown in the prototype, the main source of data for Slidecontroller is the user audio source. So the computer's microphone picks up the audios, and then the computer stores the data. which is analyzed by a different algorithm depending on keyword options selected by the user. The first important step is the computer keyboard control, which convert the control key that control the slide transition into command. Then it is the hardware detection, where the user will use the default keyword. And the last one is if the user chooses to customize their own keyword, if the user chooses to customize his own keyword, where the slide controller will automatically switch to voice recognition mode and combining the above three main section with the post-process GUI screen, which is the user interface, the user can operate more convenient and smoothly presentation. So like I mentioned earlier, there are three main core that made up the slide controller, and I will be explaining these three main core with a small portion of the code. So first, it's the keyboard control. This is the very first step that was used to control the slide using the up and down key on the computer keyboard. Generally, in the absence of a slide remote, the presenter can only use the up and down keys for the computer for control. And the slide remote itself uses this method too. What I mean by the slide remote is the traditional slide remote. And so as shown in the following code, the next function for switching to the next slide is used as example. And the first step is to define the page number accumulator to keep track of our slide number, and accumulator is being defined. And then using the keyboard press function in the keyboard module is to let the keyboard automatically click the forward button. And the keyboard simulator is the basics of the whole slide controller. And the final product, it's made up by adding voice controls to the keyboard controlling. Next is the hardware detection. I think this word is pretty commonly heard before because Siri and Alexa uses the same technique as a voice active, which it's using a always listening custom voice command, and it also uses a technique called train branded wake work. And the goal and the purpose of using a hardware detection in slide controller is to reduce the delay on switching slide, which results in faster pace, and there is no language limit. So if the presenter chooses to use a other language rather than English, they could also use slide controller during their presentation. So like show on the right side, I implemented the Pickle Voice, which is a company that held the hardware detection libraries. And by combining the previous set's keyboard control with hardware detection, the slideshow can be controlled by touching the next, previous, and thank you keywords to complete the slideshow control command in time. And as shown in the code, a web browser opening technique was added also to allow the user to copy the slide URL, and then the computer will automatically convert it to present mode, and making it more convenient without the need for user to do it by hand, and allowing audience to better understand the content of the slide after zooming in. Lastly, I uses the traditional voice recognition, which is different from hardware detection, because this is also implementing always listening, but it have a extra steps of speech to text. And it allows the user to customize the keyword by using this algorithm, and which also gives the user more creativity on what they want to use while they're controlling the slide deck. So as like on the right side, there's also a small portion of code that shows like how this would been done. And this first confirmed that what the user specified the keyword, like for example, if I put in like, please go to, the slide controller will able to store this text, please go to, while they're always listening to the user voice input. And while the user stop talking, the audio file will able to do a process, which is like quantization, and then to pick up the data point to convert that audio file into text. And from that text, the slide controller will able to know that the user put in please go to as their customized keyword. Then it will activate the command by going to the user required place, like the user required slide page. And this is basically the overlook of the final slide control. So if you look at on the left side, there is a Mac and Windows selection, which I mentioned earlier that voice recognition should be at least able to do the requirements of working on both Windows and iOS platform. And followed by the selection of a platform, there is a insert a link here, which allows the user to insert their slide link, which is the HTTP link that they could just copy directly from the top of their slide. And there's like short instruction on saying next for the next slide and say previous for previous slide and say thank you at the end to stop the app from keep running. And these instructions are not for the customized keyword. Instead, it was used for default option where the user could use these three keywords in the hardware detection algorithm so that it will run faster and then more accurate. I recommended this to be used in like a school presentation where like it's like a really chill environment where the student could just like simply by saying next or the next slide if the teacher doesn't provide them with a slide remote. And lastly, there is a slide history, which if the student or like the user wants to like store their slide history, then they could just click save buttons by saving their slide history. So it's better, it's more convenient for the next time when they wanted to present again. And after all of the steps has been complete, the user can just click start presentation by saying next previous to control their slide. And also, of course, on the right bottom corner, there's a question mark that giving like more specific instruction, which is shown on the right of the screen that the user could follow if they couldn't understand it. And this is the overlook of the default option of the slide controller. But if the user wanted to be more creative and given more freedom, they could click on the create your keyword button to create their own keyword. And here's the create your own keyword GUI, which is the same thing. You insert your slide link, but then what is different is that the user could just directly enter the keyword when you want the slide to go to a next slide, and also of course for previous slide, and then also to stop the program, whether if you don't want to say thank you, rather you want to say like thank you for listening. And the same thing on the right bottom, there's a question mark that giving the user more specific instruction. And also there's 3 bullet points that have like the notes on it so that the user will be aware of. Like one keyword will take about 2.5 seconds to the function to activate or 1.6 seconds. And also if one of the box is empty, for example, if the user doesn't input any keyword for the next function, then the user could still use the default keyword, which is just next, without inputting any keywords on there. And there's a back arrow at the bottom, which if the user wanted to go back and use the previous algorithm, which they think maybe it's more convenient that they could go back to that too. It doesn't affect the slide controller to run overall. And lastly, I would like to talk about the experiments that I did to find the best solution for solving the challenges that I have mentioned earlier for slide controller. So the testing process, there are 2 major experiments that I have done. The first one is voice recognition libraries, which basically using different libraries to compare. And second is the algorithm comparison, which is hardware detection and voice recognition, which might sound familiar because I use both of them in slide controller, but there is still a necessary of comparing those if there's like if it's possible to implement hardware detection algorithm into the customized keyword so that it will run as fast as the default option keyword that will like react in less than 1 second. So this is the voice recognition libraries comparison. And as shown on the charts above, like there is a differences between the Google recognition and assembly AI is only a fraction of a second. So but this 1 second could make a big change while you are presenting, and it might affect audience feelings on your presentation, because if there's like a huge gap between when you switching slide, that might cause a unnecessary silence. So in order to improve that, in the 15 testing process, the assembly AI seems more to be stable and accurate than the Google recognition in terms of general trends. And Google recognition is a popular speech recognition system that does not require appointments and is not used to software development. And considering the target audience, assembly AI, on the other hand, it is a paid speech recognition library, but it's only costing a fee of $5, so you could use it as many times as you want. And however, there is no differences between the two speech recognition libraries in general, but Slidecontroller requires higher sensitivity, so assembly AI is a better and the cost is more reasonable, so the user do not have to worry about the financial burden. Secondly, which is the hardware detection, and I use this to compare between algorithm to see which one will go better, and it ended up being that the hardware detection, which is provided by the Pickle Voice platform, to shows that then the purpose of this is just to show that the user, like which one it's better visualize the operation and response time of the two different programs so that they can be more secure when choosing either one. It is also to ensure that the user select the appropriate function for the presentation, since Pickle Voice provide hardware detection only with the default option, which is next and previous. Except the ending. So except the ending keyword like thank you, the user wouldn't need to use that, but then the next and previous are pretty important to control the slide pace. And compares to the voice recognition, which you can see there's a huge difference when it got onto more than 5 words. So I will be recommending the user, if they just giving like a short and quick presentation, they should use hover detection to catch up the space, to catch up the pace. And voice recognition, it's more, as you can see, for like a more serious situation where the user have a longer time of doing their presentation. As their keyword get larger, it will take longer to process and do the corresponding requirements. And lastly, I wanted to talk about more for like future development. So first of all is the voice recognition. I will be considering training my own libraries, and I'll be recording my own voice saying like different variety of keyword that will be possibly provided by the user. And by doing that, I will like post surveys on my social media to make sure people fill them out, and then to see like different possibility of keyword that they might provide and or they might want to have. And secondly is the accuracy. So to improve the audio processing and quantization, what we will do is that we will limit the user to a specific seconds of time that they need to say for the keyword. For example, if they want to say like a keyword in like 5 seconds, then we could just record that 5 second only to improve the pace of speech to text processing. And third is the variety. So I was thinking to create this method where like the user could able to add a keyword to activate the command on each slide, so that they're not limited to just saying next and previous for going to next or going to previous slide. And as well as the customized keyword where the user could only say that keyword for the rest of the slide deck when they wanted to switch a slide. So I wanted to able to provide more freedom with that. in the future development, and also, of course, Bluetooth. So like I mentioned earlier in the challenges, the environment's requirements are really high for Slidecontroller, whereas there should be no like really big voices that might affect the audio file when receiving. So I was thinking to implement a Bluetooth method that could better receive user voice. So lastly is sensitivity. So sensitivity is really important for Slidecontroller because the user will for sure want the slide deck to react once they say the keyword. So to do that, it is also connected back to like voice recognition, where like the libraries will need to able to do the audio to do the audio file processing really quick, so that it will able to improve the accuracy of detecting users keyword. And in conclusion, Slidecontroller it's a wonderful desktop application designed to assist like presenter in becoming more confident in their presentation. And users are not limited to a single keyword option, which they could use the customized keyword. And also they don't need to only limit it to working with the default keyword. And also the goal of this was just really to help the people that are afraid of presenting to like reduce their anxiety, and also they don't need to worry about like switching their slideshow while they're presenting, so that they feel more comfortable and their verbal and their hand structure could be used as well while they're presenting to make the whole presenting environment more enjoyable and more vivid. And thank you for listening. And Slidecontroller was actually already held in my GitHub page. So if you're interested, please go by just by typing in Slidecontroller. And if there's any question, you could also feel free to email me. Thank you.